spectacular ways. Especially our organs. Our kidneys have a filtration system. Each of the two kidneys contain 1 million nephrons. Each nephron includes a filter called the glomerulus and a tubule. Located at the beginning of a nephron in the kidney, glomerulus is a tiny ball-shaped structure composed of capillary blood vessels actively involved in the filtration of the blood to form urine. The glomerulus filters your blood and the tubule returns needed substances to your blood and removes waste. The glomerulus receives its blood supply from an afferent arteriole of the renal arterial circulation. The efferent arterioles form a convergence of the capillaries of the glomerulus and carry blood away from the glomerulus that has already been filtered. Let us get an expert's perspective.
Kidney is made up of around 1 million of nephrons. We mentioned that each of the arteries splitting and splitting and splitting and going into very fine twigs, and these glomerular nephrons. So each and every of the nephron of the kidney does its small bit in filtering the blood and concentrating the blood. So this is called the functional unit or a single nephron. So each and every nephron actually regulates how much blood it is filtering, which we call a single Nephron GFR or single nephron glomerular filtration rate. Glomerular may be hyperfiltering, so unlike their filtration at a resting rate of some like 80 liters per minute, they start functioning 20% or 50% more than the capacity to filter just by changing the blood supply coming from the afferent arteriole and the efferent arteriole by these pressure changes.
Unlike most capillary beds, the glomerular capillaries exit into efferent arterioles rather than venules. The resistance of the efferent arterioles causes sufficient hydrostatic pressure within the glomerulus to provide the force for ultrafiltration. Efferent arterioles begin to form the venous system and subdivide into another set of capillaries known as peritubular capillaries. They further divide into vasa recta which surround the loop of Henle. Blood then leaves the kidney and enters the venous circulation. The purpose of these vessels is to supply to capillaries located in the medulla. Difference between the blood flow of the renal cortex and medulla plays a significant role in the regulation of tubular osmolality. In the blood, there are two components, red blood cells and white blood cells. Plasma is the liquid component of blood, in which red blood cells, white blood cells and platelets are suspended. It constitutes more than half of the blood's volume and consists of water that contains dissolved salts, electrolytes and proteins. Let's say if there is 100 ml of plasma entering into glomerulus, around 80 will go through and 20 will get filtered at the glomerulus. So it's 20%. That is the normal filtration fraction. Let's say if you had intake of non-veg or high salt in your diet, the kidneys will sense the quantum and will filter the additional salt or toxins. It will dilate the afferent arteriole and constrict the efferent arteriole, increase the filtration pressure by filtering extra, hence modulating the filtrate fraction. This is part of kidney's process of autoregulation. Autoregulation manages these changes in GFR and renal blood flow. There are two mechanisms. First is called myogenic mechanism. Second is called tubuloglomerular feedback. Myo means muscles. This is about the smooth muscles that's in the walls of the vessels. When the pressure of the vessels increases, the vessel stretches. Calcium iron enters into smooth muscle cells. This leads to the smooth muscle contracting. That leads to vessels getting constricted, so it does resist being stretched, and that is how it keeps the flow intact. The second mechanism is feedback from the renal tubule of the glomerulus. This happens via a group of structures which is called juxtaglomerular apparatus. That has three parts: the macula densa, which is modified cells of the distal convoluted tubule; Extraglomerular mesangial cells, which are outside of the glomerulus and modified cells of the afferent arteriole, also called the juxtaglomerular cells or the JG cells. This entire structure forms juxtaglomerular apparatus. The JG cells are the ones that produce renin. Renin is a hormone secreted by the kidney. It is part of the system that regulates blood pressure. When there is low arterial pressure or if the renal blood flow is low, that will reduce the capillary hydrostatic pressure in the glomerulus. If that's low, that means there's going to be less filtration. Less filtration will reduce the level of sodium chloride reaching the distal convoluted tubule. Macula densa senses this and tells the juxtaglomerular cells that there is low sodium chloride. The JG cells then produce renin. Renin converts angiotensin into angiotensin 1 and then angiotensin converting enzyme ACE, it converts into angiotensin 2 and it acts on afferent arteriole and constricts it. The capillary pressure of the glomerulus increases. That means there is more filtration. GFR increases and sodium chloride levels get fixed. Macula densa also acts on the afferent arteriole and dilates it. That also contributes to increasing the hydrostatic pressure in the glomerulus and increasing the filtration fraction. So, despite the change in the renal arteriole pressure or renal blood flow, the filtration fraction is maintained. If the sodium chloride levels are high, then again the macula densa will release adenosine, which acts on the afferent arteriole that constricts it. This leads to reduced renal plasma flow. There is low capillary pressure in the glomerulus, so the filtration fraction is reduced. The rate at which the blood is filtered is called glomerular filtration rate, GFR. GFR is measured at the whole kidney level and also at a single nephron level. When single nephrons start filtering more at an individual level, it is called hyperfiltration. Hyperfiltration can happen due to certain abnormalities that may happen inside the body over time, such as diabetes, blood pressure, obesity, to name a few of the commonest. Talk about a person with healthy kidneys, his or her nephrons might hyperfilter due to consumption of high protein. A healthy kidney is blessed with its renal reserve thanks to millions of nephrons. The capacity to increase GFR happens due to renal functional reserve, and it's the loss of this reserve that indicates possible kidney damage. Let's say there is someone who is diabetic. The kidneys are hyperfiltering and doing it constantly at a single nephron level. Now when that happens, after doing it rigorously over a period of time, the nephrons eventually start to give up. And that is where we see kidneys getting damaged.
As the kidney becomes weak, two things occur. One, the number of nephrons keeps on declining. So if the number of filtering units is going down, your kidney is shrinking in size, its overall filtration capacity goes down. So that is one physiology that is occurring, that as the kidney ages or becomes weak, the number of these nephrons go down. But at the same time, there is a phenomena called autoregulation, that the nephrons have a capacity to increase their filtration capacity. The blood vessel which is bringing the blood and the blood vessel which is taking the blood away from the nephron, they have some muscles in it and they can actually dilate and constrict over there. So this dilatation and constriction actually regulates the pressures in the capillary bed or the glomerulus, and they regulate the filtration capacity of each and every nephron over there. And these are very finely regulated in the kidney. It's not just a random regulation. They are under a neurohormonal control. It has a tremendous capacity to increase the filtration and sometimes decrease the filtration. And this is done by hemodynamic methods, by changing the blood pressures across the glomerular tuft.
To control the hyperfiltration and prevent the nephrons from further damage, the doctor would advise a diabetic person to reduce protein and salt in his or her diet. Also prescribe medicines such as ACE inhibitors, angiotensin receptor blockers, SGLT2 blockers. Conclusion. So we talked about how the kidneys function. role of nephrons, what happens when nephrons start overworking, and factors that may cause damage over time. Inspiration behind this video. Help you become more aware of the basic system, as it can empower you to be more vigilant and take corrective actions before it's too late.